Alright, so we have the quadratic formula here. And let's talk about the discriminant. So the discriminant is what's inside the root here, which is b squared minus 4ac. And this symbol is called delta. It looks like a triangle, but it's called delta. And that's what you use to signify the discriminant. So delta equals what's in the root, which is b squared minus 4ac, the discriminant. And now, if this discriminant, and what we can use it for is to find out how many roots a quadratic equation has. So if the value of the discriminant is greater than 0, then there's 2 real roots. And the graph might look something like this. It's going to cross the x-axis twice. So it's going to touch it twice. And then if the discriminant is equal to 0, then it has 1 real root, in which case it only touches the x-axis at the vertex and nowhere else. And if the discriminant is less than 0, then there's no real roots, and the graph is not touching the x-axis at all. So it could look like this. It could also look like this. Same goes for these other two. These can be like this. And this can also be like this. Okay, so let's use a discriminant to solve this problem. It says, find the discriminant and its meaning. So we know that the discriminant, delta, equals b squared minus 4ac. So here we have a quadratic equation. We can just label a, b, c. So a is 1, b is 7, and c is negative 3. So if we put it into this formula, b squared minus 4c, we'll get 7 squared minus 4 times a, which is 1, times c, which is negative 3. So 7 squared is 49, and 49 minus 4 times negative 3 is negative 12. So 49 minus negative 12 is just 49 plus 12, which is 61. And since we can say that delta is greater than 0, we can just say that there are 2 real roots. And then this is the discriminant. Okay, so let's do number 2 here. So it's the same problem, find the discriminant and its meaning. So again, we have delta as b squared minus 4ac. So let's say a is 1 again, b is 1 as well, but this time c is 5. Okay, so if we plug into this formula again, we'll have b squared, which is 1 squared, minus 4 times a, which is also 1, times c, which is 5. So 1 squared is 1, minus 4 times 5 is 20. So 1 minus 20 is negative 19. And since we know that if the delta is less than 0, then this has no roots. Because since negative 19 is less than 0, we can say that this has no roots. Okay, so the last question of this type. So we have 16x squared minus 8x plus 1. And then, so we have b squared minus 4ac. And then we have, this time, a actually is not 1, it's 16. And then now we have b as negative 8. And c is equal to 1. So let's plug it back in. So b squared, which is negative 8 squared, minus 4 times a, which is 16, times 1, because c is 1. And then negative 8 squared is 64, minus, and then 4 times 16 is 64, and 64 times 1 is still the same, so 64. And now you can see that it's actually 0. And remember that if delta equals 0, then there's only one real root. And the discriminant is 0. Okay, so this problem's a little different. So it says find the values of m for which the equation has one root. So here we have x squared minus 2x plus m. So we have two unknown variables. But it asks us find m for which it has one root. So that means the discriminant has to equal 0. So we have a as 1, b as -2, and c as m. So we plug it into the discriminant, which is b squared. So -2 squared minus 4 times a, which is 1, times c, which is m. So we can just say m. So -2 squared is 4, minus 4 times 1 is 4, and then 4 times m is 4m. So minus 4m. So this is the discriminant we have for now. And now it says for one root. So if we're saying the discriminant equals 0, so that means 4 minus 4m also has to equal 0 because that's what the discriminant is. So we subtract 4 both sides. We have -4m equals -4. So that means m equals 1. And that's what the value of m should be here if the equation has one root. Okay, so the next part says the same thing, find the values of m for which the equation has two roots. Now instead of one, we have two. And it's the same equation, and since the same equation, we know that the discriminant is 4 minus 4m. And we also know that since it's two roots, the discriminant has to be greater than 0. And since this is what the discriminant is, 4 minus 4m has to be greater than 0. So now we subtract 4 on both sides. And then we have -4m is greater than -4. 0 minus 4 is -4. And now we divide by -4 on both sides. And now we switch it. So we say m is less than 1. Because when you divide by a negative number, when you have an equality, the sign switches. But if you were to divide with a normal, just without a positive, if you were to divide with just 4, then this stays the same. But since we're dividing by a negative, this is going to switch. So m is less than 1, which means that for the equation to have two roots, this value of m right here has to be less than 1. Okay, so the last part of this question is find the values of m for which the equation has no roots. So since it's the same equation again, we know that the discriminant is 4 minus 4m. And we also know the discriminant is less than 0 now. So now we can say 4 minus 4m is less than 0. So now we subtract 4 on both sides, and we have -4m is less than -4, and we divide -4 on both sides. And again, since we're dividing by a negative number, we swap the sign, so we now say m is greater than 1, because -4 divided by -4 is just 1. So now what this means is that for this equation to have 0 roots, so no roots, this value of m has to be greater than 1.